Welcome to this video tutorial. In this session, we'll dive into the late DID recognition process. We'll explore why it's needed, how it differs from the three authentication methods, and the logic it uses to manage on-net call routing. Let's recall that Sippy uses different authentication methods for different types of call originators, allowing for distinct routing paths and charging mechanisms. The remote authentication type in the DID pool section is mainly for DID providers, with or without specifying the provider's remote IP. Account authentication rules work best for peer carriers and wholesale traffic, authenticating calls from their gateways with flexible matching based on remote IP, incoming CLD, or incoming CLI. Digest authentication is for devices like soft phones or PBXs with dynamic IPs, verifying calls using the account's username and password. The challenge is that calls authenticated using the authentication rules or digest authentication methods cannot be routed directly to DID pool entities, requiring an additional step to resolve routing to the DID pool's destinations. Late DID recognition is a powerful tool that addresses this specific issue by allowing calls that fail remote DID pool authentication, but are successfully authenticated via authentication rules or digest authentication, to still be routed to the DID pool's assigned entities. For example, soft phone devices typically use dynamic IP addresses. Therefore, calls originating from such soft phones must be authenticated via digest authentication, as they cannot be matched using a static IP-based rule. Once authenticated, if the call needs to be routed to a DID destination, the late DID recognition feature is applied. The system searches the DID pool for a matching DID number with the late type enabled and then routes the call to the entity assigned to that DID record. Discussing late recognition in isolation can be confusing, so we created this diagram to show the DID pool late recognition process within the context of all post-authentication call routes. It illustrates the complete paths leading to late recognition, contrasts them with other routing options, and highlights how all routes are related. As we covered in the previous video, an incoming call must first pass through one of the three core authentication stages: remote DID pool authentication, account authentication rules, or digest authentication. The late DID recognition process becomes relevant only after a call has successfully passed either the account authentication rules or digest authentication. As shown in the diagram, there are three possible routes for a call to reach late DID recognition. Regardless of the path, the key setting that determines whether a call is routed to late DID recognition is the on-net use connection parameter in the routing group. If this parameter is set to default, the call proceeds to an on-net lookup. Other values, such as a disabled, will result in a different, off-net routing path. Once the on-net lookup begins, the system first searches for a matching CLD in the list of all accounts. If a match is found, the call is forwarded to that account's incoming routing feature for processing. The system then evaluates the incoming routing rules to find a matching entry for the call, ultimately sending it to the specified destination, such as a registered user agent, UA, or a trunk. If the on-net lookup fails to find a matching account, the system then performs a late recognition search. It will look for a DID in the DID pool that matches the dialed number and has this late recognition rule enabled. If a match is found, the call is routed to the account or customer assigned to that DID record. It is important to note that routing to an IVR is not supported by the late recognition process. Finally, once the call is sent to the matched account, the process concludes with that account's incoming routing settings, for example, by sending the call to a registered device. The system will not perform another late recognition lookup that prevents potential routing loops. To conclude, we've seen how late recognition acts as a vital bridge. It allows calls that have already been authenticated by other methods, such as from a registered user agent, to be intelligently routed to a specific destination in your DID pool. With the DID pool remote authentication and late recognition fundamentals covered, let's trace the call to the next stages of the DID call routing process. In our upcoming tutorials dedicated to DID management, we will dive into more details and explore the different paths a call can take after a successful remote authentication or late recognition, tracking it all the way to its final destination, whether it's a user agent, a follow-me number, a trunk, or more.